Hello everyone, I hope you all are well. In this video, we'll talk about binomial distribution. So let's begin. Binomial distribution is a discrete probability distribution which is used when there are only two possible outcomes. So in our day-to-day life, we come across many experiments which have only two outcomes. For example, when you toss a coin, it either shows head or tail, right? So there are only two outcomes. When a company is manufacturing some item, it can be defective or non-defective. So in such cases, binomial distribution is used. And in such case, we take one of the outcome as success and the other outcome as not success or failure. For example, in the case of tossing a coin, we can take coming up of head as success and coming up of tail as failure, right? So in such cases, binomial distribution is very useful. Probability mass function of binomial distribution is given by this formula. We have already discussed what is probability mass function in my previous video, right? So probability mass function case of binomial distribution is given by this formula. It represents probability at any point x. Okay, it is given by NCx, p raised to power x, q raised to power n minus x. N is the total number of trials. P is the probability of success and Q is probability of failure. And this NCX, I'll talk about this NCX right now. N and P are the parameters of binomial distribution. Now, let's see what is this NCX. This is binomial. NCX is the binomial coefficient. Value of NCK is given by this formula. NCK is equal to n factorial upon n minus k factorial into k factorial. And what is n factorial? N factorial is n into n minus 1 into n minus 2 up to 3 into 2 into 1. For example, if you want to find out 3 factorial, what will be 3 factorial? It will be 3 into 2 into 1, which is equal to 6. If you want to calculate 5 factorial, it will be 5 into 4 into 3 into 2 into 1. Okay. 0 factorial is always taken to be 1 and 1 factorial is always 1. Okay. So if you want to find out 5C2, what will be 5C2? It will be 5 factorial upon 5 minus 2 factorial into 2 factorial. So 5 factorial as it is, 5 minus 2 is 3 factorial into 2 factorial. So we'll expand 5 factorial as 5 into 4 into 3 factorial. Okay, and we'll keep 3 factorial as it is because we can cancel 3 factorial with this 3 factorial and 2 factorial as 2 into 1. So this 3 factorial get cancelled with this 3 factorial. So what we get, 5 into 4 divided by 2 into 1, which is equal to 10. NCN is always 1. If you calculate NCN, it is n factorial divided by n minus n factorial into n factorial. So n factorial upon 0 factorial into n factorial. So n factorial get cancelled. We get only 1 upon 0 factorial, which is equal to 1. So NCN is always equal to 1. You can calculate this. NC0 is also 1. NC0 is n factorial upon n minus 0 is n factorial into 0 factorial, which again comes out to be 1. What is NCn minus 1? This is equal to n factorial upon n minus n plus 1, which is 1 factorial upon n minus 1 factorial. So if you expand the n factorial, which is in numerator, it will be n into n minus 1 factorial. It will get cancelled with n minus 1 factorial in the denominator and you will get only equal to n. Let's discuss one problem. A die is thrown 6 times. If getting an odd number is success, what is probability of 5 successes? So here in this problem, n is 6 because we are throwing the dice for 6 times. So there are 6 number of trials. If getting an odd number is success, so what will be the probability of success? How many odd numbers are there when you throw a die? 3 odd numbers, right? which is 1, 3 and 5. So 3 upon 6 is the probability of success, which is equal to 1 by 2. And what is the probability of failure? Q equal to 1 minus P. It is given by 1 minus 1 by 2, which is equal to half. Okay. So N is 6, P is half, Q is half. We have to find out the probability of 5 successes, which means we have to find out we have to find out P5. If X denotes the number of successes in 6 trials, we have to find out P5. So by using binomial distribution, what is P of X? P of X is equal to NCX, P raised to power X, Q raised to power N minus X. So P5 will be equal to NC5. Instead of X, put 5 here. So NC5, P raised to power 5, Q raised to power N minus 5. Now put the value of N, P and Q. N is 6. Put the value of N equal to 6, P equal to half and Q equal to half. Now how we can open up this NC5? This can be opened up into 6 factorial upon 6 minus 5, 1 factorial into 5 factorial. Into 1 by 2 raised to power 5 into 1 by 2 raised to power 6 minus 5. This 6 minus 5 can be written as 1, right? So this is equal to 6 factorial into 5 factorial upon 1 factorial into 5 factorial. 1 upon 2 raised to power 5 and 1 by 2 raised to power 1. 6 minus 5 is 1. So this 5 factorial get cancelled. We are left with only 6. This becomes 1 by 2 raised to power 5 plus 1. When base is same, powers can be added. So 5 plus 1, 6. So this is equal to 6 upon 32. So probability of 5 successes when you throw dice 6 times is 6 upon 32. So let's discuss what is the mean of binomial distribution. In my previous video, I have discussed about the mean of probability distribution. So mean of any probability distribution is given by summation x varying from 0 to n x into p of x. And in case of binomial distribution, p of x is ncx, p raised to power x, q raised to power n minus x. Now what we'll do, we'll put the value of x, we'll open up this summation, we'll put the value of x equal to 0, then 1, then 2 and so on to n. So we are opening up this summation now. So we'll get, when you put 0, you'll get 0 into nc0, p raised to power 0, q raised to power n minus 0. Just instead of x, put 0. Then plus, now instead of x, put 1. So 1 into nc1, p raised to power 1, q raised to power n minus 1. Now next put 2 nc2, p raised to power 2, q raised to power n minus 2 plus so on, and the last put n. Instead of x, put n. n into ncn, p raised to power n, q raised to power n minus n, 0. So q raised to power 0. Now we'll open up this binomial coefficients. Okay, the first term will become 0 because 0 is being multiplied with the whole term. The first term will become 0. So we'll get first term as 0. Second term, NC1. Now what is NC1? NC1 is n. If you calculate NC1, it is equal to n factorial upon n minus 1 factorial into 1 factorial. So open up the factorial in the numerator. Expand the factorial in numerator, you will get n into n minus 1 factorial. N minus 1 factorial and n minus 1 factorial get cancelled. You will be only left with n. Okay, let me explain you this properly. What is nc1, right? nc1 is equal to n factorial upon n minus 1 factorial into 1 factorial. Now we can open up this n factorial as n into n minus 1 factorial upon n minus 1 factorial into 1 factorial. So this n minus 1 factorial will get cancelled with this minus n factorial. We are only left with n, right? So here nc1 is n, p raised to power 1, q raised to power n minus 1 as it is. Now expand nc2 in the similar way. What will be nc2? NC2 will be equal to n factorial upon n minus 2 factorial into 2 factorial. Now expand the n factorial in numerator. So this is equal to n into n minus 1 into n minus 2 factorial upon n minus 2 factorial into 2 factorial. So this will get cancelled. We'll be left with n into n minus 1 upon 2 factorial, and 2 factorial can be written as 2 into 1. So we get this n into n minus 1 upon 2 into 1. P square as it is, q raised to power n minus 2 as it is, plus 3 n into n minus 1, n minus 2 upon 3 into 2 into 1. Similarly, the third term, you can calculate the third term. The third term will be this, plus so on in the last n. NCN, what is NCN? NCN will be 1 into p raised to power n as it is, q raised to power 0, anything raised to power 0 is 1, so we'll be left with only n into p raised to power n in the last term. So now here you can see n is common from all the terms, n can be taken out. P is common from all the terms, so p can also be taken out. Okay. Q is not there in the last term, so we'll take out the common terms n and p outside the bracket. So taking n and p outside the bracket, here we are left with q raised to power n minus 1 only, plus taking n and p common, 2 get cancelled with this 2, so we are left with n minus 1. P 1 p is taken out, so we are left with p only, q raised to power n minus 2, plus 3 get cancelled with this 3, we are left with 2 into 1. N is taken out, n minus 1 as it is, n minus 2 as it is, p square into q raised to power n minus 3, plus so on. N is taken out, p is taken out, so we are left with p raised to power n minus 1 only. Then what we'll do now, we'll write these coefficients in term of binomial coefficient. So q raised to power n minus 1 as it is, this is the binomial coefficient n minus 1 c1. You can check this. N minus 1 can be written as n minus 1 c1. P into q raised to power n minus 2 as it is. This can be written as n minus 1 c2. P square q raised to power n minus 3 as it is, plus so on in the last. 1 can be written as n minus 1 c n minus 1. P raised to power n minus 1. Why I am taking n minus 1 here? Because I want to use binomial theorem here, right? So this term will be reduced to p plus q raised to power n minus 1. We have applied binomial theorem here. You can see that. So this will be p plus q raised to power n minus 1, and p plus q is 1. Okay, p plus q is 1, so we are left with n into p only. So mean in case of binomial distribution is np. Remember this. Next we will discuss variance of binomial distribution. Variance of any distribution is given by expectation of x square minus expectation of x whole square, which is equal to expectation of x square. Now expectation in case of binomial is mean. Expectation is mean only, and mean in case of binomial distribution we have just discussed, it is equal to np. So we have put np here. Now expectation of x square. Expectation of x square will be equal to summation x varying from 0 to n, x square into p of x minus np whole square. Now just put value of p of x here. So this is equal to x square ncx p raised to power q raised to power n minus x, other terms as it is. This is very important step now. We can write x square as x square minus x plus x. I have just added 1x and I have subtracted 1x, right? We can write x square in this form. Now from these two terms I have taken out x common, so inside it will be 1x minus 1 plus x Now I have just uses the commutation law here. I have written x in the front plus this term in the last. So I can write x square. I can write x square as x plus x into x minus 1. So this is very important step. So we'll write x square. We'll write x square here as x plus x into x minus 1. Now we'll open these brackets. So we'll have two terms here. X is being multiplied here, summation x varying from 0 to n, x into ncx p raised to power x q raised to power n minus x, plus summation x varying from 0 to n, this being multiplied here, x into x minus 1 nc x p raised to power q raised to power n minus x minus np square as it is. Why I have done this? Because this is expectation of x, this is mean, so that's why I want to make a mean here. That's why I have done like this. So this is the value of mean here, so this will be equal to np. This term will be equal to np. Here I'll put the value of x term by term and we'll open up the summation. So firstly when we put x equal to 0 here, it will become 0, the whole value will become 0. Then put x equal to 1. When you put x equal to 1 here, this term will again become 0. So now put x equal to 2. So we'll get 2 into 1 nc2 p raised to power 2 q raised to power n minus 2 plus now put 3 into 2 nc3 p3 q raised to power n minus 3. So on in the last put n, then we'll get n into n minus 1 p raised to power n minus np square term as it is. Next what we'll do, we'll open up these binomial coefficients. So nc2 is n into n minus 1 upon 2 into 1 p square q raised to power n minus 2. nc3 is n into n minus 1 p minus 2 upon 3 into 2 into 1 other terms as it is. Okay. Now what we'll do, we'll take out the things which are common from this term. Here you can see p square is common, n into n minus 1 is common. So we'll take out the common terms from here. So taking out n into n minus 1 and p square common, from here we get q raised to power n minus 2, this get cancelled. Then taking out n outside, n minus 1 outside and p square outside, we are left with n minus 2. 3 into 2 into 1 get cancelled with this 3 into 2. So we are left with n minus 2. 2 p square goes outside, so we are left with p only, q raised to power n minus 3 plus so on in the last. N goes outside, n minus 1 goes outside the bracket, p square go outside, so we are left with p raised to power n minus 2 minus np whole square. Now this is again here we'll use the binomial theorem here. So we'll change the coefficient into binomial coefficients. So this n minus 2 will become n minus 2c1. So on last one will become n minus 2 cn minus 2. Okay, I'll write this whole equation again on the next page. So we have this. Now we can use binomial theorem here. So by binomial theorem this will become np as it is plus n into n minus 1 p square as it is. Here we are applying binomial theorem. So here we get q plus p raised to power n minus 2 minus np whole square, and p plus q is again 1, so we get np plus n into n minus 1 p square minus np whole square. Now just open up these brackets, so we get np into np square n square p square minus np square minus n square p square. So this n square p square get cancelled with this n square p square, we are left with np minus np square. Now take out np common. So we are left with np into 1 minus p, and 1 minus p is q. So variance of binomial distribution is npq. So mean in case of binomial distribution is given by np and variance is given by npq. There is one important relationship between mean and variance of binomial distribution. Variance of binomial distribution is always less than mean. You try to do this. Okay, if you find any problem, you can You can tell me in comment section. I hope you have understood this video. If you have any doubt, please ask me. Thanks for watching this video. Have a good day. Thank you.